Now that we've seen what the graphs of the sine of t and cosine t function, let's do an example where we sketch the graph of this transformation, negative cosine of x plus pi over 2. Before I do that, I want to go back to our sketch here, and I want to show you how you can sketch this very quickly, much more quickly than when we made this table and plotted all of these points. So let's start out with sine of t. So I'm going to erase the graph, and then I'm going to show you how I would graph sine of t if I was doing a transformation problem. Now I understand that this is not a transformation because it's just sine of t, but the methodology that I'll use will be as if this was a transformation problem. So the graph of sine of t is trapped vertically. That is, it's always between +1 and -1, and it's split in the middle by the t-axis. So here we have this top, y equals 1, this bottom, y equals -1, and this y equals 0, which is called the midline of the graph. And now to sketch sine of t, what I'm going to do is I'm not going to worry about the x-coordinates such as pi over 4, pi over 3 pi over 4, 5 pi over 4, etc. I'm only going to sketch the points at 0, pi over 2 pi, 3 pi over 2, and 2 pi. And in fact, every transformation problem that you do, you'll include 5 x-coordinates. They may be different x-coordinates for each problem, but they'll be 5 x-coordinates. And for sine of t, the behavior of that graph is it starts at 0, that is, it starts at the midline, then it goes up to the top line at the second of the 5 points, then it goes back down to the midline at the third of the 5 points, or better said, maybe the third of the 5 x-coordinates. Then at the next x-coordinate, it goes down to the bottom, and then back to the middle, and we can connect with a smooth curve. And of course, you can sketch the graph of cosine of t in a very similar way. So if we erase all these here, all we have to do is, instead of starting at the middle like we did for sine of t, we'll start at the top. We'll go to the t-axis at the next coordinate, the next x-coordinate. Then we go down to the bottom. We go back to the middle, the midline there, and then we go up top to 2 pi, and then we can connect with a smooth curve. Knowing this pattern for cosine of t, top, midline, bottom, midline, top, and the pattern for sine t of midline, top, midline, bottom, midline will be essential for understanding how to sketch the graphs of trigonometric functions quickly. Now, in order to do this for transformations of functions, you have to know a few things. You have to know the top, the midline, and the bottom line, and you have to know these 5 x-coordinates here. So let's go ahead and record what we need to know in order to sketch this graph. The first thing we'll need is the midline and the top and bottom line. Then we'll need, let's call those x-coordinates the important and I suppose I've been using t, so let me switch this example from x to t. So let's put t here, and let's call these important t coordinates. So the important t coordinates, that's these that I've circled here. Then once we get those, we'll sketch the graph. Most of the work here comes in steps 1 and 2. And the way that we will obtain the information that we need in step 1 and 2 is we'll apply transformations. So let's start with step 1. Let's see how this goes.